Thank you everyone for attending. Today I am going to talk about my experience working on state-driven graph visualizations and some of the ways that it changes your thinking compared to more traditional imperative application designs. So as it says on the slide, my name is Kevin Naughton and I am a product manager here at Cambridge Intelligence. My focus has mostly been on a product that is quite new for us. It's called ReGraph, and it was released about 9 months ago. So I'd like to talk today to anyone in particularly who is involved currently in building a graph visualization. And we're going to focus on the two questions that you can see on this slide. So how is state-driven graph viz different? And how can state-driven design improve my application? We've been thinking a lot about these questions here at Cambridge Intelligence since we released this new product, ReGraph. And ReGraph is a graph visualization toolkit that is specifically designed for React developers. So let me tell you a bit about React. This is a JavaScript meetup, so I'm sure most of you have heard of it, but React is a popular front-end JavaScript framework. And there are two important points for those who are maybe not too familiar with it. So the first one is that React is declarative, and that means that all the information being displayed by your application is held in a central place called state, and all changes that users make in that application go through the state, and when a user makes a change, you as the developer update the state, and that then updates your application. React is also component-based, and this means that each element in your user interface is self-contained, and it manages the changes itself each time your state is updated. Now, no presentation would be complete without a couple of definitions to get things started, so here are mine. I want to make clear the difference between a more traditional imperative approach to graph visualization and the declarative or state-driven approach that I'm advocating for today. So in the imperative model, the developer controls everything that the chart does, and they're entirely responsible for the whole user experience of anyone using the chart. So the developer tells the component to run this layout, add this data, change these nodes. In the declarative or state-driven model, the developer changes their data, and the chart component decides how to handle these changes. So the component is going to ask questions like, are there new items to add? Is a layout needed? Have any items been changed? And each of these questions is answered by the component, and the component will then move from the previous state to the new state with a nice animation. So to summarize, data is an input for the chart. And changes to the data are driven by the chart in the imperative model, whereas in the declarative application, the data is changed and the chart is merely the thing that shows the data. So let's look at a simple example here now. We've got a very, very exciting graph visualization. It's got a single node and it's got a button that changes the color of that node when you click it. So this particular example is probably a lot easier in the imperative world, right? You're gonna, the user will click, you'll find the correct node, and you'll change the node's color. In the declarative world, it's a bit trickier. You have to find the state, find the correct node in the state, update the node color, then update the state. This seems like extra steps, but it turns out that the declarative model scales really well, and that is where you start to see some advantage. So here's a second example. Let's say we want to add and remove some items from the chart and make sure that it always looks nice and doesn't have too many edge crossings as you add more data. So the imperative approach starts to seem very long, right? I won't read them out, I'll let you read them. But by comparison, if you look at the state-driven approach, you start to see why it's helpful. We've got basically the same steps as before, right? The user clicks, you get the state, you add and remove things, you update the state. So as you can see, it scales better, and by letting us make multiple changes at once in a single state update, we don't have to think too much about the order that we do things, and that takes a lot of the complexity out of the code of your own application. Another advantage is when you start to look at having multiple UI components in the page. So suddenly we can pass the same state object to a table, a pie chart, a complicated graph, and changes that you make in one place can be kept in sync with another because everything is using the same state. Another interesting thing to think about with the declarative approach is filtering. This is an important part of the graph visualizations that we work on, and defining your own property-based filtering logic means that analysts using your application can focus on the most interesting connections in your network. So here we're looking at a graph of some web vulnerabilities, and we might filter out Adobe Flash to see what a flash-free internet might look like. So again, looking at the two different approaches, you basically think of filtering in exactly opposite ways. So in the imperative app, we look at and put together a list of all of the things that we need to remove from the visualization, and then we tell the chart to remove the items that are on the list. In the declarative app, we build a list of the things we want to keep, and we pass that updated list back to the chart to take care of. But it can actually be quite easy to get that list of things you want to keep in a lot of tech stacks, because your front-end code, unlike in the imperative model, in the declarative model, your front-end code doesn't need to figure out what has changed in the data. You can just pass the new data to the chart component, and it'll take care of those sorts of difference calculations. All the items that were already in your chart stay exactly where they are, and anything that's no longer needed is then removed. Another interesting point of difference is the way that each approach thinks about layouts. So in the imperative model, a layout is an action that is triggered by the application or by the user. You perform a layout. In a state-driven application, a layout is instead more of a mode. And so as data is added or removed, the chart works to maintain the look of that layout. Whether it's a complex force-directed layout, as you can see on the left-hand side, or whether it is something like a hierarchy, which you can see on the right. Lastly, I'd like to touch on an issue that I often encounter when talking to people about graph visualization. So they'll say, I want to see all of my data on the screen at once. I even had one customer who had so much data that they wanted to see that there would have been more nodes on their chart than there were pixels on the screen. And while the products that we make, they can handle tens of thousands of items on the screen at once, and they can maintain high performance while they're doing it. But the end users of applications like that are going to get pretty limited insight from seeing a sea of data. They'll then have to do all sorts of aggregating and filtering in order to get down to something manageable, and that's probably not the best use of professional analytical skills. So There's still this idea, though, that we should throw all of the data at the user and let the user decide what to do with it and to filter it down. And I think some of this approach might be driven by the idea that data is an input for the chart and that all the changes to the data should be driven by the chart. So if we turn this idea on its head and argue that the data is the thing being changed and that the chart is merely showing us the data, then perhaps we can design more intuitive graph visualizations, which start with a small amount of data, maybe an interesting cluster of nodes or a specific question that needs to be answered. And if we start small, we can easily add more data to our chart as it's requested. And then we can provide users with tools to interrogate their data rather than tools to sort through it. Now, the jury is still out on whether a state-driven approach leads to better application design more of the time, but I'm hopeful that we will start to see evidence that it does make a difference. So you might be sitting there going, well, I don't use React. How is this going to help me? So I've got a couple of messages that I think everyone can take away for their next graph visualization project. And these are really inspired by those lessons learned from state-driven approaches. So firstly, focus on your data. Focus on what your data contains and the questions you want to answer. UI and UX design is important, but don't get distracted or bogged down by the shape of the buttons that your analysts are going to press. Let a graph visualization component take care of how to display things and how to handle new data. And you can then pay attention to what insight you want your users to find and which threats they need to reveal. And secondly, it's your data that makes your visualization unique. So lean into that and make sure that users can see the right amount of data at the right time. Thank you very much for listening. I hope you found some of that compelling. And if you would like to try out a state-driven library for graph visualization, please get in touch. You can see my email there on the screen. And I am now going to hand over to Corey.
Thank you, Kevin. So now what we're going to do is we're going to take a look at the